A long time ago, in a galaxy far, far away. Wouldn't have made sense a long time ago, because we didn't know about galaxies a long time ago. Back in the ancient days, we didn't have the tools we have now, and because of that, we were pretty naive about a lot of things. Although, I would argue we're still pretty naive about a lot of things, because based on how quickly our tools advance, even in 100 more years, I bet we're going to learn some crazy new things about our universe that are just going to blow our minds away if we're alive that long. Unit 1, Ancient Astronomy. Alright. So, it all starts here on Earth, because that's where we are. And since we are the center of our universe, we tend to think of everything relative to us. So, on this little speck of dust in the universe, a 15,000 kilometer speck of dust, the third planet from the Sun in an 8-planet speck of dust solar system, this is our home. With lots of water, lots of life, nice thick atmosphere to protect us from the cold vacuum of space, strong magnetosphere to protect us from the cold, hard radiation of space. Shouldn't really say cold, it's pretty energetic, not necessarily hot, but damaging. And this is our star. You look up in the sky, all you see are stars everywhere. Billions, billions, and billions of stars. The thing is, they're so far away that we really can't see billions of stars because they're not bright enough for us to see all of them. We need telescopes, which have only been around for a few hundred years, to be honest. And so before that, we were pretty naive as to what was going on in the universe. Who would have thought that our sun is just a star like any other star? We just happen to be close to it. Our sun is an average medium-sized yellow dwarf star, average in temperature, average in age, average in size. I might argue, it's pretty average in size. Think it's kind of like NBA players, right? Most people are not that tall, but when you put all those tall people on one court, then they look normal. But if you put a random sample of people in a line, most of them won't be that tall. Same idea. We see the brighter stars, the bigger, brighter stars in the sky because they are bigger and brighter, easier to see. But there's a lot of stars that we don't see, and those make up the average. Those are like the normal height people. Our sun is not going to live forever. It's basically like any fuel source. Once you use it up, it can't burn anymore. Luckily, there's enough fuel to burn for 10 or so billion years old, 9 to 10 billion years. It's a long time, and we're about halfway through it. So, you know, not much time left. I always find this puts it in perspective just how long 5 billion years is.
Here's the plan. We get the warhead and we hold the world ransom for $1 million.
Well, don't you think we should maybe ask for more than $1 million? $1 million isn't exactly a lot of money these days. Virtucon alone makes over $9 billion a year.
Really?
Mm-hmm.
It's a lot. Okay, then. We hold the world ransom for $100 billion.
Awesome. Yeah, $100 billion. If you had $5 billion, you'd be sitting pretty, huh? So that's quite a lot. 5 billion years. We might not even make it well, definitely, the the sun won't be nice and stable like it is now for the entire rest of its life. It's going to start getting bigger and become a red giant. So for that phase of its life cycle, we won't really be able to survive. But let's say for the next 3 billion years, that's a long time to survive. If you look at the archaeological records that we have so far, even the dinosaurs who lived, I don't know what, few 100 million years, if I remember right, even they didn't live forever. So, although arguably their ancestors are still around in some form or another, but yeah. So let's hope we can live long enough as a species to see this. Although, if we live that long, we'll have to figure out somehow to move away from this system and find another system. Uh, Whether that remains something in the realm of science fiction is to be seen. Not by us, though, that's for sure. And then our little tiny sun would be somewhere maybe around here in our galaxy. A galaxy is a gathering of billions of stars. All of these little bright specks here are stars. There's just so many that, and we're so far away that you can't see it. This picture is an artist rendition. There's no way we could take a picture of the Milky Way because we are in the Milky Way. It's like trying to take a picture of the forest with no way to get into an airplane and fly above the forest. You'd only be able to take the picture of the inside, which is what we can do. Another thing why we can't see individual stars is because we're so far away. Just like if you're in an airplane, you can't see individual leaves on the tree. It all looks like a sea of green. That's why, if you were to get closer, you'd start to see individual stars, including our little sun here. Nice average sun. Our galaxy is 1,000 quadrillion kilometers across, which means nothing. And really, neither does this. In light years, it's 100,000 light years across, which really means nothing because even though, yeah, okay, it takes 100,000 years or so for light to make its way across our galaxy, who knows? Really has a good sense of what 100,000 years is? It's a vast amount of time. But we're pretty sure that our galaxy is a spiral galaxy. If you ever read The Hobbit, there's a scene where they're in Mirkwood where they get Bilbo Baggins to climb a tree and see if they're near the edge of the forest because they're stuck in this dark, evil forest. So Bilbo climbs up and he's blinded by the sunlight and it's like beautiful out and there's butterflies flying everywhere and they actually are close to the edge of the forest, but because they're in a valley, Bilbo can't see it because they're like down and the edge of the forest is up too high to see, so it looks like the forest goes on forever. Um, we don't even have that luxury. We can't climb a tree and get on top of the galaxy and see if it really is a spiral or not. We have to use other clues because even our Voyager probes are only just reaching the edge of the solar system, which is nowhere close to a boundary on the edge of the galaxy. So huge. Our place in space. So you zoom farther out, and all you see are galaxies. If you see a star in this picture, that means it's really close, and you won't see many because this is just a really small little pinhole piece of the sky zoomed in, and these are all galaxies. You see all these lines here. This is something called gravitational lensing, which we'll talk about later. It's really kind of like light bending from behind because of the gravitational effect of the closer galaxies. And then the Hubble Deep Field. I'll show you better pictures with the picture of the day. This is a little grainy, but Hubble Deep Field is again just a zoomed in picture of a tiny pinhole size piece of the sky. And two stars in this picture? 2 stars anymore? Yeah, this tells you how zoomed in it is because usually when you look at the sky, you just see thousands and thousands of stars in a picture, but this is so zoomed in that we can only see a couple stars. And the rest are galaxies. Each of these galaxies has billions and billions of stars. Oh. And then, look, these are all galaxies back there, just farther away. It just so happens that Hubble can't see that far. Can't really zoom in that. Well, maybe it could, but it just for this picture it chose this focal length. But just galaxies, so many possibilities. We would never. I mean, the chances of us ever reaching this is probably zero. Even if the science fiction world of Star Trek comes to life and we develop warp speed, even in that science fiction world, that warp speed allows us to travel in our lonely galaxy pretty quickly. It takes a while to go across our galaxy, let alone to another galaxy. So yeah, this is pretty much out of our reach. Pretty much. Ancient astronomy. So we've always had the sky. In fact, viewing the sky was better back then because we didn't have all the city lights polluting the sky and blind overpowering the stars. City lights are brighter than the stars, and so most stars anyway. So we can't see all the little dim stars up there. But the ancients found astronomy useful for lots of things, including getting around, navigating, determining the time, not just of the night, but of the year, planting and harvesting crops, knowing what time of the year to start planting, because the seasons follow the skies very closely. Here's an ancient tool, still used today, but an ancient tool used for navigating. Sextant. Stonehenge. It's thought that it's an ancient kind of astronomical observatory or calendar because of the fact that the sun at certain points in the year falls just at certain points of the structure. This is located in England and took about 1700 years to build. Can you believe that? 1700 years. That's, if you divide, let's say, 4 generations per century, that's 17 times 4 is 40, almost 80 generations. Maybe like what, 70 something generations? Huh? Can you believe that? Building this thing? How do you keep up the motivation all those years? Pretty intense. In North America, we got a couple interesting little things: bighorn medicine wheel and caracal. Caracal was built around 1000 AD by Mayans, and its windows align with astronomical events, including solstices and equinoxes. We'll talk about those in a little bit. More recently, we got the ancient Greeks. Actually, no, this is Greeks were before this. What am I thinking? Um, Even before that, we got the ancient Greeks. This is what, probably in the late BC, just before we turned to AD, uh, developing the math that we still learn today. Can you believe this? The math that you learned as either a sophomore, freshman, or a sophomore, or maybe even earlier or later, was developed thousands of years ago, and we still think it's important enough. It is important enough. It's some of the more fundamental laws of physics are based on the Pythagorean theorem. It's kind of crazy. Uh, Aristotle concluded that the Earth was round, and he used the fact that the moon and the sun were round as clues to this. And I might need to stop the video now. One more slide. Chinese astronomy, they kept very accurate records of weird stuff like comets, and they actually recorded a supernova, a star that blew up in 1054 AD, which we can now see as the Crab Nebula, and we'll see pictures of that at some point. It's kind of interesting that so long ago a star would have blown up, and it's still, the remnants of that are still around. Alright, let's pause this and do the next video. Continue on the next video. See you then.